This is a recording for notes for math analysis, and this is section 04, nth roots and real exponents. We're on part 2 now, where we're going to be simplifying expressions in exponential form. And we're going to start by kind of just thinking about what really a fractional exponent is and means, or rational exponents. So rational numbers are written as fractions. So we're going to kind of develop this, and it's on the next slide as well, but I like to kind of think our way through it as we go. So if we let the square root of b, equal b to some power, the nth. And then, like, we want to get this b alone, so we want to get rid of that radical. So we're going to square both sides. And oops, so now I'm gonna, I kind of thought that through. That's what I'm gonna do. So I'm gonna take this square root of b equals b to the n, and I'm gonna square both sides. And then the square root of b squared on the left is just b. And then I can just rewrite this as b to the 2n. And so then kind of think about this. That's like b to the 1 equals b to the 2n. And so if the bases are both b and 1 is equal to 2n, I can kind of do a little sub equation and say, well, these exponents must be equal as well. And so I'm going to write that 1 equals 2n. And then to solve for n, we'll divide each side by 2. And so 1/2 is equal to n. And so then I'm going to go back up to this, and I'm going to say, oh, n is equal to 1/2. So that means the square root of b is equal to b to the n, which is 1/2. So when we see b to the 1/2, that's going to mean the square root of b. So if I see b to the 1/5, that's going to be the 5th root of b. And if I see b to the 2/5, that's going to be the 5th root of b squared. Okay, and let's just do one more. If I see b to the 6/5, that's going to be the 5th root of b to the 6th. And then let's kind of simplify that based on our earlier part of this section. So that's going to be the 5th root of, I can break that into b to the 5th times b to the 1st. And so that'll be the 5th root of b to the 5th, times the 5th root of b to the 1st. And the 5th root of b to the 5th will be b, the 5th root of b. And so we can use these fractions to write things as in a radical and kind of go back and forth. So that's kind of just this development at the top of this slide. So I'm not going to just reread that. But the big thing we want to get out of that is that the square root of b is b to the 1/2. And so we can do that for any nth root. And this next piece here, I do want you to write about rational exponents, but I think this is a little hard to see, so I'll be rewriting these kind of as I read them. So if b is a real number, variable, algebraic expression, m and n are positive integers greater than 1, then here's what we get. This first bullet is that b to the 1/n is equal to the nth root of b. If, and we'll just, I'll put in parentheses, if the principal nth root of b exists. So, if this all works out. And then the second bullet here is b to the m/n is equal to the nth root, because the n is on the bottom of that fraction, of b raised to the m power. Or we can say it another way, b to the m/n is also equal to the nth root of b to the m. And we'll also add for that one if m over n is in reduced form. Reduced form. So we do want to make sure that that's the case. So of these two versions, kind of whichever one is more convenient for us, you know, and I would say the way I judge that is if this is going to be a perfect nth root, I would just kind of take that out and then put it to the m power after that. And likewise, if this is, let me get rid of that one too. If this is going to make that maybe better for my nth root, or I can kind of pull out some of them but not all of them, then I might use that version. So notice just that you can use both versions of that as you go. So now we'll do number 3, and these do take some practice, and so maybe we'll try to designate some class time over a couple days to kind of look at that as we're maybe even moving on. I'm not sure. With this hybrid model, it's a little tricky for me. So 3a is the 10th root of 32 over the 6th root of 2. And you want to be pretty well versed with your powers of 2. And so 32, maybe I'll go way over here. So 2 times 2 is 4. Times 2 is 8, times 2 is 16, times 2 is 32. So 1, 2, 3, 4, 5. So that was a 2. 2 to the 5th equals 32, just to kind of keep that in mind. So there's kind of several ways that we can do this. We'll put it in these fractional exponents and see what happens. Because when I'm noticing this, I notice these can both be written as 2 to a power, and then I can just use my fact that if I have a fraction, I'm gonna and I'm dividing and they're both bases of 2, I'm just gonna subtract. So this is, I can rewrite as 32 is 2 to the 5th. So I can say this is 32 to the 1/10. So over 2 to the 1/6. And then 32, remember I just said is 2 to the 5th to the 1/10 over 2 to the 1/6. And then this is 2 to the 5/10 or 2 to the 1/2 over 2 to the 1/6. Then I can just use the fact that I can subtract powers when I have a situation like this. I'm just going to move that a little out of my way. And so this is 2 to the 1/2 minus 1/6. And I'll just rewrite it over here. 2 to the 1/2 minus 1/6. I'm going to get a common denominator. So I'll multiply this one by 3 over 3. And then that's going to give me 2 to the 3/6 minus 1/6. Oops. And that's going to give me 2 to the 2/6 or 2 to the 1/3. So if I want to leave it as a fractional exponent, I could. If I wanted to put it in radical form, it would be the cube root of 2 as we go. And so that's kind of an illustration of how to do a problem like that. Do read over this little watch out thing. Be careful with rational and negative exponents. B to the -1 does not equal B to the 1 over n. B to the -n equals 1 over B to the n. And B to the 1 over n is equal to the nth root of B. So if you want to write something down about that, pause this and go ahead. Now we have 2 more problems, and I'm going to extend my page just a little to make those kind of be at the top. So this is 3b, and for this one we have the 4th root of x to the 21, y to the 15. Now, we can do this 2 ways, kind of the way we did it last time will also work, and then just using that method. But since we're going over this fractional exponent thing, I want to do it that way too. And then I'm going to tell you kind of a hybrid model that I kind of use in my head as I go through these. So for this one, I'm going to say this is x to the 21 over 4 and y to the 15 over 4. I'm going to write it over here though, 21 over 4, y to the 15 over 4. And because I just want to do a little computation over there. So I'm going to take 21 and divide by 4. That goes 5 times, and then that's 20, and then I have 1 left over. So I'm going to say that 21 over 4 is equal to 20 over 4 plus 1 over 4, because then this is going to be a whole number as I look at that. And so, oops, I'll just leave that circle there. And so that's one thing I'm going to do. Then I'm going to do something similar with y. So I'm going to divide 15 by 4. And that's going to go 3 times. That's 12 and 3. So I'm going to say that is that 15 over 4 is equal to 12 over 4 plus 3 over 4. And so I'm splitting it up. It's still 15 over 4, and that other one's still 21 over 4. But now I'm kind of putting my things that are going to be whole numbers kind of together, so to speak. So I'm going to say this is x to the 20 over 4. And listen, because I added these, that means I'm multiplying the actual things as I go. So times x to the 1 over 4. So kind of think about your, old time multiplying powers. You add the exponents if the bases are the same. And so if I multiplied these again, I would get 21 fourths as I go. And same thing with y. I'm going to say it's y to the 12 over 4 times, and these are all times y to the 3 over 4. And so that's still, this all is equal to that as I go. And then the next thing I'm going to do is I'm going to push this one, well, not quite like that. I'm going to push this one into the front a little more and then kind of change the position of those two, because the ones that are whole numbers wouldn't be in radicals. So I'm going to say this is equal to x to the 20 over 4 times y to the 12 over 4. Those are going to be whole numbers, times x to the 1 over 4 times y to the 3 over 4. And then what I'm going to do is I'm going to just fix those, reduce those down, and I could have done that earlier. And then these two I'm going to put back in a radical, and they're both fourth roots, so that's how I'm going to write them. So my final result is, oops, my final result is x to the 20 divided by 4 is 5, y to the 12 divided by 4 is 3, and then I'm just going to write the rest of this as the cube, or the fourth root of x, y to the third. And so there is my answer for that one. And now we'll move on to letter C. And I think you'll see that sometimes this makes an easier problem kind of following this, because those last two were maybe seeming a little. So then for 3C, oops, we have 16 to the 3/4 over 16 to the 1/4. Now, if in the last couple of problems, or that first one on 3A, you were thinking, oh, I'd rather just change it into radicals and pull things out. Well, really, that would be to your disadvantage in this one. And 16, is 2 to the blah, blah, blah. But look at this. These bases are already the same. So, and the exponents have the same denominator. So our rule is that we can just take 16 to the 3/4 minus 1/4, and 16 to the 3/4 minus 1/4, 16 to the 2/4, which is 16 to the 1/2, which is the square root of 16, which is 4. Oh, lovely. That was like my favorite problem. So that is what's happening in this one. Let's take a moment, because there aren't a lot of problems listed here. And let's just take a moment and have us pause this, and we'll have you do number 3, these two problems, and then share the answer. So pause this a moment, and I will likewise, because I have to actually do them, and then we'll have the key there for you. So hopefully you've had a little time to work these out, and you'll see these on the PDF as well. And so here are the answers, so you can check your work. And then I added another slide where I kind of just showed how to work them out. So here's my work on these two problems as well, and I tried to give a few little notes there as I went along. And if that was too fast or you don't want to pause it, it is on the PDF as well. So that concludes the notes for 04. And so you should be working on homework 4. Have a good day.